Circular motion is the movement of an object in a circular path. Uniform circular motion. If the magnitude of the velocity of the particle in circular motion remains constant, then it is called uniform circular motion. Non-uniform circular motion. If the magnitude of the velocity of the body in circular motion is not constant, then it is called non-uniform circular motion. If an object rotates around itself, the motion can be called spinning motion. Variables of circular motion. Angular displacement. Angular displacement, delta theta, is the angle subtended by the position vector at the center of the circular path. Therefore, delta theta equals to delta s by r, where delta s is the linear displacement and r is the radius. Its unit is radian. Angular velocity. The rate of change of angular displacement, delta theta, with respect to time is called angular velocity, omega. Omega equals to limit delta t tends to 0 delta theta by delta t. Therefore, omega equals to d theta dt. Angular velocity is a vector quantity and its unit is radian per second. Relation between linear velocity and angular velocity. We know omega equals to d theta dt, or omega equals to 1 by r limit delta t tends to 0 delta s by delta t, because delta theta equals to delta s by r. Therefore, omega equals to v by r, where v is linear velocity and is equal to ds dt. Angular acceleration. The time rate of change of angular velocity is called angular acceleration. Alpha equals to limit delta t tends to 0 delta omega by delta t. Therefore, alpha equals to d omega dt. Therefore, alpha equals to d2 theta dt square. Unit of angular acceleration is radian per second square, and dimensional formula is t to the power minus 2. Relation between linear acceleration and angular acceleration. We know alpha equals to d omega dt, or alpha equals to 1 by r dv dt, because omega equals to v by r. Therefore, alpha equals to a by r, where a is the linear acceleration equals to dv dt. Kinematical equations in circular motion. Relations between different variables for an object executing circular motion are called kinematical equations in circular motion. Omega equals to omega 0 plus theta t. Omega square equals to omega 0 square plus 2 alpha theta. Theta equals to omega 0 t plus half alpha t square, where omega 0 equals to initial angular velocity, omega equals to final angular velocity, alpha equals to angular acceleration, theta equals to angular displacement, and t equals to time. Centripetal acceleration. In circular motion, an acceleration acts on the body, whose direction is always towards the center of the path. This acceleration is called centripetal acceleration. Centripetal acceleration, Fc equals to limit delta t tends to 0 delta v by delta t. Therefore, Fc equals to v limit delta t tends to 0 delta theta by delta t, because delta v equals to v sine delta theta, or delta v equals to v delta theta, as delta theta is infinitesimally small. Therefore, Fc equals to v omega. Therefore, Fc equals to v square by r, because omega equals to v by r. Centripetal acceleration is also called radial acceleration as it acts along radius of circle. Its unit is meter per second square, and it is a vector quantity. Centripetal force. It is that force which compels a body to move in a circular path. It is directed along radius of the circle towards its center. For circular motion, a centripetal force is required, which is not a new force, but any force present there can act as centripetal force. Centripetal force, F equals to mFc, equals to mv square by r. Work done by the centripetal force is 0 because the centripetal force and displacement are at right angles to each other. Some examples of centripetal force are: gravitational force between planet and sun provides centripetal force for orbital motion of planets. Electrostatic force between electron and nucleus provides centripetal force for orbital motion of electrons. Frictional force acting between tires of vehicle and road provides centripetal force for turning of vehicles at turn. Tension in the string provides centripetal force for circular motion of a stone tied with a string. Centrifugal force. Centrifugal is a fictitious force which is equal and opposite to centripetal force. It appears when centripetal force ceases to exist.